possible to create a black hole in a laboratory? This is a question that has piqued the curiosity of many. Black holes, the mysterious celestial bodies that lurk in the farthest corners of the universe, have long been subjects of fascination and intrigue. These celestial entities, known for their insatiable appetite for matter and their ability to warp the fabric of space-time itself, captivate us with their enigmatic nature. They represent the unknown, the unexplored, the unseen, and it's this allure of the unknown that keeps us coming back, wanting to learn more, to understand more. But can we, with our current understanding and technology, create a miniaturized version of these cosmic monsters in a controlled environment? Could we really bring a piece of the cosmos into our own backyard? Let's delve deeper into the mystery of black holes before we attempt to answer this intriguing question. To understand if we can create a black hole, we first need to understand what a black hole is. Imagine a star, much larger than our sun, reaching the end of its life. This star, having spent millions of years burning through its nuclear fuel, finally exhausts its energy source. The outward pressure of the energy being generated within the star can no longer withstand the massive gravitational force pulling everything inward. The core collapses under this immense gravity, and in a spectacular explosion known as a supernova, the outer layers of the star are blown away. What remains is an incredibly dense core. If this core is dense enough, it forms a black hole. A black hole is an area in space where the gravitational pull is so strong that not even light can escape its grasp. This intense gravity forms a boundary around the black hole called the event horizon. Anything that crosses this event horizon is consumed by the black hole, never to be seen again. At the center of a black hole, we find a point known as a singularity. This is where the laws of physics as we know them break down. The singularity is a point of infinite density and gravity, a concept that challenges our understanding of the universe. Black holes have been the subject of fascination and study for centuries. They're the ultimate cosmic monsters, inescapable gravitational titans that consume everything in their path. Yet, they're also invisible, hiding in the darkness of space, detectable only by the effects they have on their surroundings. Theories about black holes range from the scientific to the fantastical. Some suggest that black holes could be portals to other universes or dimensions. Others propose that they might be the engines of creation, spewing out matter and energy that form new stars and galaxies. Now that we have a basic understanding of black holes, let's examine the challenges in creating one. Creating a black hole is far from simple. There are numerous challenges to consider. First and foremost is the need for immense mass and density. You see, a black hole is an area in space where the gravitational pull is so strong that not even light can escape it. To create such a gravitational pull, you would need a mass several times that of our sun, compacted into an incredibly small area. This is not something that can be easily replicated in a lab setting. The second challenge is creating the conditions for a black hole to form. In the universe, black holes are born from the death throes of massive stars. When a star around 3 times the mass of the sun exhausts its nuclear fuel, it collapses under its own gravity and forms a black hole. Replicating these conditions in a laboratory would be, to say the least, challenging. But let's say for a moment we could overcome these hurdles. That brings us to the third challenge, the potential dangers. A black hole, even a small one, would have a gravitational pull strong enough to start drawing in its surroundings. This could lead to a chain reaction that could potentially consume our entire planet. Not the kind of experiment you want to get wrong. One might wonder why even consider creating a black hole in the first place. Well, black holes are fascinating objects that could hold the key to many of the mysteries of the universe, including the nature of gravity, the properties of light and energy, and perhaps even the fabric of reality itself. Understanding black holes could revolutionize our understanding of the cosmos. Despite these challenges, scientists have tried to simulate black holes. Let's explore these attempts. Simulating black holes might sound like science fiction, but scientists have made attempts. They've dared to delve into the unknown, reaching into the fabric of our universe to understand these cosmic enigmas better. One such attempt is the sonic black hole experiment, which, mind you, doesn't involve any actual black holes. Instead, it's a clever experiment designed to mimic some of the properties of a black hole. In the sonic black hole experiment, scientists create a flow of ultra-cold atoms. This flow is then accelerated to a speed that exceeds the speed of sound in the medium. This setup creates a point of no return, beyond which sound waves cannot escape, much like the event horizon of a black hole. While it's not a genuine black hole, it gives researchers a way to study some of the black hole's unique characteristics in a controlled environment. Then there's the use of high-energy particle accelerators. These are massive machines that propel particles to nearly the speed of light, smashing them together to create extreme conditions. Theories suggest that these conditions could potentially create tiny black holes, but hold your horses, it's not as dramatic as it sounds. These would be microscopic black holes evaporating almost instantaneously due to a phenomenon known as Hawking radiation. So far, though, these elusive entities have remained undetected. These experiments are intriguing, giving us a glimpse into the mysterious world of black holes. They offer valuable insights, helping us refine our theories and deepen our understanding of these cosmic phenomena. But it's important to remember that these are simulations, not the real deal. They mimic certain aspects of black holes, but they're not the full package. These experiments shed light on black holes, but they fall short of creating an actual black hole. Now let's wrap up our discussion. So can we create a black hole in a laboratory? Well, let's take a moment to reflect on the journey we've taken today. We started by exploring the enigmatic nature of black holes, these fascinating celestial bodies that have the power to warp space and time itself. We learned about their immense gravitational pull and the way they can distort the very fabric of reality. Then we ventured into the realm of human ambition. We considered the possibility of creating a black hole right here on Earth in our own laboratories. Through this exploration, we discovered the immense challenges that stand in our way. The sheer amount of energy required, the potential for catastrophic consequences, and the limitations of our current technology all present significant hurdles. We also delved into the world of simulation, exploring how scientists use advanced computer models to study black holes. These digital renditions allow us to observe and analyze the behavior of black holes in a safe and controlled environment. But even with these simulations, we're still far from creating a real black hole in a lab. The idea of creating a black hole is both thrilling and terrifying. It's a testament to human curiosity and our unending quest to understand the universe. But it's also a stark reminder of our responsibility. With great power comes great responsibility. And the power to create a black hole is certainly no exception. The potential dangers of creating a black hole cannot be overstated. Even a microscopic black hole could have catastrophic consequences, consuming everything around it. It's a risk that, for now, we simply cannot take. So, where does this leave us? Well, the truth is we're still far from being able to create a black hole in a lab. But that doesn't mean we should stop asking questions, exploring possibilities, and pushing the boundaries of our understanding. While black holes continue to fascinate us, creating one in a lab remains, for now, beyond our reach. But who knows what the future holds for our understanding and manipulation of the cosmos?